Hi and welcome to Manifest Maths. This lesson we're going to look at transformations of graphs and the main transformations that you need to know for Unit 1 AS level mathematics. We're going to be looking at transformations such as y equals AF, y equals f of x plus a, y of f of x plus a with the transformations inside the bracket, and then y equals f of ax where the transformation is a multiplication inside the bracket. These are the four main types you need to know. Okay, so you want to pause the video and write this information down. These are all the transformations that you require to know. So the first one, we have y equals f of x plus a. This will push the graph in the y direction. It will translate the graph in the y direction by a distance of a. Y equals f of x minus a will translate the graph in the x direction by a. And what you'll notice here is that if we have minus a, that will move the graph to the right, which is quite counterintuitive. You could have a combination whereby you've got minus a inside the bracket and plus b after. This will move the graph up in the y direction by a translation of b, and to the right by a translation of a. You could also then get reflections, which are these two. So if you've got y equals minus f of x, that will be a reflection in the x-axis of the graph, and y equals f of minus x is a reflection in the y-axis. And the last two are scalar transformations. So for example, you might have y equals a f of x. This will stretch the graph in the y direction, and it'll end up multiplying the y coordinates by whatever that scale factor is. And then counterintuitively, if you have a transformation such as y equals f of ax, this will be a stretch in the x direction of the scale factor 1 over a. So this kind of transformation here will what we call compress the graph inwards in the x direction. Okay, this video might be slightly different to the other videos in so much that we might just work through questions in sequence. Okay, so let's just jump straight in with the question. What you'll notice with this question is we have a graph that looks quadratic in nature, could be. We don't necessarily need to know what the function is. We're just going to be given it as y equals f of x. And we notice that there are two roots and a minimum point at these coordinates. The question is asking you to sketch the following graphs using a separate set of axes for each graph. In each case, you should indicate the coordinates of a stationary point and the coordinates of the points of intersection. So what we're looking at here is seeing how this graph moves around and what will happen to each of these 3 points. Okay, so let's have a quick look at what this one will look like. Okay, so for part A, we have the transformation y equals f of x minus 5. And remember, this will be a translation using the following vector. We have minus 5, so it's going to move the graph 5 to the right. Okay, and the y coordinates aren't going to be affected at all. So let's have a quick look at what this graph will look like. We've got our y and our x. And what we notice here is that each of our x coordinates, okay, will have 5 added onto them. So the new coordinate sets will be the following: minus 6 plus 5, 0. That's the first root. Then 2 plus 5, 0. And then finally minus 2 plus 5, minus 7. You'll plot these points now. So minus 6 add 5 is minus 1. So our first root will be here, minus 1, 0. The second one, 2 plus 5 is 7. So that'll be over here, 7, 0. And our minimum point will now be at minus 5 plus 5, which is 3, minus 7. So around about here, 3 minus 7, and then we will join them up. It'll be the same graph, only pushed over 5 to the right. Okay, For part B, in this case, we have the transformation y equals f of x over 2. Now this is going to be what we call a stretch in the x direction of 1 over a. Now what we notice here is that our a value for this one is half. So our stretch is going to be 1 over a half, which is equal to 2. And so we're going to multiply all our x coordinates by 2. Okay, so for our 3 coordinates, we're going to have minus 6 times 2, 0. The y coordinates won't be affected by this transformation. Then we're going to have 2 times 2, 0. And then finally, minus 2 times 2, minus 7. And then we can sketch where these coordinates are going to be. So the first one, minus 6 times by minus 2 is minus 12. So our roots are moved further out to say minus 12, 0. 2 times by 2 is 4. So it's going to be a 4, 0, the second root. And then minus 2 times by 2 is minus 4, and down at minus 7. And what you'll notice is we'll have a bit more of a stretched out curve in the x direction. In this case, I mentioned on the first page of this PowerPoint that something along the lines of y equals f of ax will generally compress the x roots in. But what we'll notice here is that we've actually got a scale factor of a half. So what that does is it pushes the graphs out and stretches them in the x direction. Okay. Right, this is one for you to try then. So if you pause this video, draw the graph and see how you get on with this one. And then I'll go through the solutions on the next slide. So in the first instance, this first question is very similar to the second part of the previous one. We have the transformation y equals f of half x, which can also be written as x over 2. Our a value is equal to half again, and this is a transformation which will be a stretch in the x direction by 1 over a, which again will be 1 over half, which will be equal to a stretch of 2 for all the x coordinates. So our new coordinates will be minus 6 times 2 again, 0. Then minus 2 times 2 with minus 3. And the third one, 2 times by 2 with 0. We can then sketch these coordinates. So we have minus 12, 0. We've got minus 2 times by 2, so minus 4 and minus 3. And then finally 4 and 0. And again, we end up with that stretched out graph in the x direction. Right, for part B, we have a fictitious transformation of the form y equals a f of x. Now remember, a transformation of the following would be a stretch in the y direction by a scale factor of a. So only the y coordinates affected. So only the y coordinates are affected. Okay, now if you consider the three sets of coordinates we've got, -6, 0, 2 and 0, and -2 and -3. What you'll notice is these two have got y coordinates of 0 anyway, so it doesn't matter what they're multiplied by, it doesn't matter what the value of a is, they're going to remain where they are. With regards to this one here, okay, the new coordinates for this point would be -2 times by -3 times a. And what you'll notice is the x coordinates are unaffected. So the reason why it won't go through the origin is because the x coordinate is not affected, and so remains as -2. It also says actually in this question that is a non-zero value of the constant a. So what that means is even the y coordinate can never be 0, because to get -3 to 0, you'd have to multiply it by 0, and it's implying that a is non-zero. But you only need one reason, and that would be the reason. Okay? Right. Pause the video and try this one very quickly. So hopefully you've had a chance to look at this question. I'm actually going to adapt this question on the original graph. We've got the scale factor of x over 2 again. So a is half. So the stretch is going to be 1 over half, which again is 2. So that's going to double the coordinates of each of these x values. So 2 times by 6 is going to give us 12, 0 as the new root. -2 times by 2 is going to be -4, 0 for the other root. And then 2 times by 2 is going to give us 4, 5 for the maximum point, and your graph is going to look something like this. One thing to consider is, can you still notice that the intercept is the same? Because remember, the intercept x is 0, and 2 times by 0 will be the same as whatever the original graph was. Okay, so that's one of the downsides of maybe adapting on the same diagram. You need to think about what your intercepts are going to be. It might have been an idea to draw it on a fresh graph for that one. Okay, another one for you to try then. So pause the video and try this one. So for part A, we have the transformation y equals f of x plus 1, where our a value is equal to 1. Now if you remember, this will be a translation in the x direction. Using the following vector, it's going to be a movement of -1, and the y coordinate is going to be unaffected. So this is going to move the graph 1 to the left. So our new coordinates for our 3 points, for the first one is going to be -6, -1, 0. Then it's going to be 2, -1, 0. And -2, -1, and -4. So we can plot these. -1, -1, -6, -1 is -7, 0 for this first root. Then 2 minus 1 is 1 and 0. And then -2 minus 1 is -3. So you have -3 and -4, which puts us down here. So the graph has been pushed across 1 to the left. Okay, part B, we have y equals f of 2x. This is going to be a stretch in the x direction of 1 over a. A is equal to 2. So our scale factor is going to be a half. So we're going to multiply all our x coordinates by a half. So we end up with minus 6 times by a half, 0. Remember the y coordinate's not affected. Then we're going to have 2 times a half, 0, and minus 2 times by a half, and minus 4. And then we can sketch where these are going to be. So we draw a new set of axes. Minus 6 times by half is minus 3. So minus 3 and 0. Then 2 times by half is 1, 0. And then minus 2 times by half is minus 1, and minus 4. And what we notice now is we have the graph coming down through, and it's being compressed in. If I was to draw it on this diagram, it would look something like this. That distance would be half of that. This would be half of that, and this new this new minimum point would be halfway in from this one. I'm drawing that very well. Okay. Right. Pause the video and try this one. See how you get on. So for part A, we have the transformation y equals f of x plus 5. This is going to be a translation of minus a in the x direction, which is going to move our coordinates using the following vector, minus 5 and 0. The y coordinates not affected, only the x coordinates. So our new coordinate sets are going to be minus 2, minus 5, 2 minus 5, 4, and 6 minus 5, 0. So the coordinates are going to be minus 7, 0, minus 3, 4, and 1, 0. And we can now plot these. X and y. Minus 7, 0. Minus 3 and 4. And then 1, 0. And our graph is going to do something like this. Come down through. Okay, right, for part B, a bit more going on with this one because there's two transformations. So we've got y equals f of minus 2x. The first transformation to deal with is probably with the minus 2, okay? So, with the 2. So the first thing to think about here is the 2 is going to be a stretch in the x direction of 1 over a, which in this case is equal to 1 over 2. So that's going to multiply all the x coordinates by a half. So let's apply that one first. Okay, we're going to apply the transformation minus 2x first. 2x first, which is going to give us the following coordinates. Minus 2 times by a half, 0, x coordinates not changed. 2 times by a half, 4, and 6 times by a half, 0. That gives us the following new coordinate sets. Minus 2 times by half is minus 1. Then 1, 4, and 3, 0. Then we've got to think about this minus f of x. This f of minus x. Now if you remember, this is a reflection in the y-axis. So I think what that means, let's say we had the coordinates here which were 2, 2, and I want to reflect them in the y-axis. the coordinates of the new reflected point should be minus 2, 2. So what you notice is the x coordinates being changed from positive to negative. So that's going to change the signs of each of these x coordinates. So the new coordinates are going to be 1, 0, minus 1, 4, and minus 3, 0. We can then plot these, giving us y and x. 1, 0 will be here, minus 1, 4, and minus 3, 0 will be here. We end up with the following graph. That's not very well drawn there, sorry. Comes up through that point and down through this one. Essentially what's happened here, if I just adapt this first diagram up here, the minus 2x has brought each of these points in by half, and then it's reflected them over, so that one's come over here, this one's come to there, this one's gone to there, and we've ended up with a graph in this position. Okay? Right, another one for you to try. Pause the video and give this one a go. There's only one part to it. This is a minus 3f of x, with the minus 3's outside. So we have the transformation y equals minus 3 f of x. Again, there's two parts to this. We have the minus 3 outside, so we're going to deal with the y equals 3f of x first. This is a stretch in the y direction by 3. So our coordinates are going to be minus 4, 0. That one's not going to be altered because 0 times by 3 is still 0. And the other root is going to stay in the same place. But the third one is going to be minus 1 and minus 3 times by 3. So that gives us the following new coordinates: minus 4, 0, 6, 0, and minus 1, minus 9. The next thing to deal with now is this minus transformation. Y equals minus f of x. This is a reflection in the x-axis. So what does that mean? All y coordinates will be reflected. So for example, if I had the point 2, 2 again, and I reflected it in the x-axis, that would come down to here, which would be 2, minus 2. This time only the y coordinates are affected. So all these coordinates now, the y coordinates will change sign. So we'll still have minus 4, 0, won't be affected. 6, 0, won't be affected. This new one will be minus 1, 9. So we can plot these three coordinate sets. We have minus 4, 0. The two roots haven't been affected at all by this question. But the minimum point now has become a maximum point, and it's going to be at minus 1. Sorry, I made a mistake with this coordinate here, didn't I? This should have been just positive 1. That's positive 1. So it's going to be at 1, 9, sorry, in this position. So the graph's going to do something like this. Okay, next one to try. Pause the video and give this one a go as well. Okay, so we have the transformation y equals minus 3 over 2 f of x. This time we've got a negative transformation and a scale factor outside. So let's deal with the y equals 3 over 2 f of x first. This is going to be a stretch in the y direction by 3 over 2. You could write that as 1.5 if you wanted to. So our y coordinates are going to be affected. So we have the coordinates -3, 0. We have the coordinates -1, -4. And we have the coordinates 1, 0. So our new coordinates, after applying the first transformation, the y coordinates are going to be times by 3 over 2, or 0 times by 3 over 2 is still 0. We have -1 and 4 times by 3 over 2. And we have 1 and 0. That gives us the coordinates -3, 0, -1. 4 times by 3 is 12, 3 over 2 is 6, and 1, 0. So that's the coordinates after applying the first transformation. Then we have to deal with the minus. We have y equals minus f of x. Again, this is going to be a reflection in the x-axis. So all y coordinates are going to change sign. So we have -3, 0, -1, 6, and 1, 0. And the new coordinates after this, all the y coordinates are going to change. So we're still going to have -3, 0. The second one's going to be -1, -6. And the last one's still going to be 1, 0. So if you were to sketch this graph, we have -3, 0 remained in the same place. We have 1, 0. And we have -1, -6. Oh, hang on, I made a mistake as well. Okay. I'm making lots of mistakes in this video. I do apologize. -4 times by 3 over 2 is -6. So that should be -6. So this should change to +6. It has to happen that way because the graph has to obviously flip upside down. So it should be a -1, 6, which is up here. So the graph does something like this. Just a little bit of exam technique as well. Indicating the coordinates of the stationary point, that's this bit, and the coordinates of the point intersection with the x-axis is the two roots. So the roots will remain constant, and the graph's been stretched in the y direction and reflected. Okay, another one to try. There's 3 parts to this question. There's a bit more going on. Pause the video and give this one a go. So for part A, we have y equals f of x plus 4. This is going to be a translation in the x direction of -4. So it's going to be a -4, 0 translation. So our new coordinates, so the original coordinates are -1, 0, 3, and 2, 7, 0. The new coordinates are going to move to -1, -4, 0, 3, -4, 2, 7, -4, 0, which gives us the following. -1, -4, so -5, 0, -1, 2, and 3, 0. So we can quickly sketch this one. -5, 0, -1 and -2. Sorry, -1, 2, and 3, 0, which puts us here, and then we can sketch through. We have our graph. Okay, so part B, we have y equals minus 2 f of x. So the first is to deal with the 2 f of x. That's going to stretch the y coordinates. So our original coordinates are minus 1, 0, 3, 2, and 7, 0. So the new coordinates after this first transformation, we're going to multiply all of the y coordinates by 2, which gives us minus 1, 0, 3, 4, and 7, 0. Then we're going to apply the transformation y equals minus f of x. That's going to reflect all the y coordinates. So our new coordinates are now going to be minus 1, 0, 3, and minus 4, and 7, 0. We can sketch that new graph. Minus 1, 0. So the roots have stayed exactly where they were. And the maximum point now has become a minimum point, which is 3 and minus 4. Down here, and the graph is going to do something like that. So it's been reflected down and stretched, giving us something like that. Okay, parts. So for this 1 mark question here, what you'll notice is on the left hand side we've got y equals f of x plus 4. That was this first transformation we did. And then on the right hand side we've got minus 2 f of x. This was the second transformation we did. And then we've got this plus 4. Now remember, that will push the graph up 4. So if you look at this minimum point on the second graph we drew, which was at the corners 3 minus 4, if we pushed that up 4, it would now be at the point 3 and 0, which would be here. And what you should notice is that is actually the coordinates of this point here. So that graph would then cut that graph at that position. So that means that one of the roots will be at the points 3, 0. Okay, so imagine pushing that minimum point up. This graph will, if I was to draw a line here, be there. And if I push this up 4, they would cross at this point. Okay, next one to try. Pause the video and give. So, next question. We've got part A, which is y equals f of x plus 2. That's going to be a transformation in the x direction of minus 2 and 0. So let's find our coordinates. We can have minus 1, 0. We've got the coordinates 0 and 2. We've got 3 and 4. We've got 7 and 0. We're going to subtract 2 off each of those. This can give us minus 3, 0. This one is going to be an erroneous coordinate because while 0 minus 2 will be minus 2, we don't know how that's going to affect the y coordinate. So this one, which is our intercept, is going to be moved across, but we don't know where that new root is going to be because we don't know what the actual curve is. Then we've got 3 minus 2, which is 1, 4, and then 5, 0 for the last one. So this first graph is going to have minus 3, 0. It's going to have 1 and 4 as its maximum point, and then 5, 0, and it's going to do something like this. Okay, we only want the point intersection with the x-axis. We don't know where this new intercept is going to be. If we knew the function, we could work out what it was. B. Then we've got y equals f of x plus 3 with the transformation outside. That's going to move the graph up by 3. And it's going to be the transformation 0, 3. So that's going to give us the following new coordinates, -1 and 0 plus 3, which is 3. 0 and then 2 plus 3, which is 5. And then 3 and 4 plus 3, which is 7. And 7, 3. You'll notice how the intercept has been affected. Okay, it's gone 3 up. So the new graph here is going to give us the following. Now again, we don't know where the roots are going to be now, okay, but we know that at 0, 5, that's our new intercept, and our new maximum point is now at 3, 7. Well, that's 3 and that's 7. So our graph does something like this. You notice it doesn't ask for where it crosses the x-axis. Okay, that's because we don't know what the curve was and we don't know where it's going to cross those axes at the bottom. Okay, next one to try. Let's go through this one very quickly. So we got y equals 2 f of x. It's going to stretch our y coordinates. So the only one that's going to be affected here is the 1 and 3. That's going to give us the new coordinates 1 and 6. So our roots are going to remain in the same place at -4 and 6. But the new maximum point is going to be 1 at 1 and 6. So our graph is going to do something like this. We weren't given the intercept, so we can't work out what the new intercept is. So you just need to mark off 1 and 6. Part B is the graph y equals f of minus x. So remember, this is the reflection in the y-axis. So the coordinates are going to be the original coordinates are 1, 3, -4, 0, and 6, 0. And for that reflection, the x coordinates are going to change. It's going to become -1, 3, 4, 0, and -6, 0, which I will draw on the original graph actually. So this is going to go over to here. This point is going to come over to -6, and this maximum point is going to be here. So it'll look something like that. You need to mark off the point intersection. So this will be 4, 0, and this will be -6, 0. Okay, another couple to try. Pause the video and give it a go. So for part A, we've got y equals 3 f of x, stretching the y direction. So we've got the coordinates 1, 0, 2, -1, and 3, 0. So the y coordinates are going to change by a scale factor of 3. So that's still going to be 1, 0. This is going to be 2 and -3 and 3, 0. So our roots, we're going to have 1, 0 still, 3, 0. But the minimum point is now going to be at 2 and -3. So it's going to look something like this. Although not necessarily quite like that, because this intersection is going to be 3 times higher up. So probably should have drawn it something like this. There still needs to be an intercept. Part B, we've got y equals f of x plus 5. It's going to be a movement to the left in the x direction, which is the following translation, minus 5, 0. So this minimum point is now going to be at the coordinates minus 4, 0. This one's going to be at minus 2, 0. And this minimum point here is going to be at minus 3, minus 1. If we were to sketch it, minus 4, 0, minus 2, 0, and minus 3, minus 1. So the graph is now going to be further over to the left. Moved across to the right, to the left by 5. Okay, another one to try. Give this one a go. First transformation, y equals f of x minus 3. It's going to be a movement to the right of 3 in the x direction, which is translation 3, 0. So our new coordinate sets, y and x, this one's going to move 3 to the right. So that's going to be at minus 2 plus 3, which is 1, 0. This one's going to go 3 to the right, so it's now going to be a 9, 0. And this one is going to be at 2 plus 3, which is 5 minus 3. And the graph has moved to the right by 3. Then we've got the transformation y equals minus 2f of x. So we'll do both of these in one go. So this is going to be a stretch in the y direction, and this is going to be a reflection in the... So the first one, the 2, is a stretch in the y direction, and the minus 2 is a reflection in the x-axis. Our coordinates are minus 2, 0, the original coordinates, 2 minus 3, and 6, 0. So a reflection in the y-axis, in the x-axis, is going to change the y coordinates. So first of all, we're going to multiply the y coordinates by 2. But for the first one, you'll notice it stays at 0. The second one, we have minus 3 times by 2, which is minus 6. Then we times it by minus 1. So it's going to change up to 6. And then 6, 0. So our new graph is going to be at minus 2, 0. Root has stayed in the same place. The other root is still going to be 6, 0. But now our minimum point has become a maximum point and has also been times by 2. So it's going to be a 2, 6. Giving us something like this. Okay, so we've gone back now to the original question from the first slide. We can probably do this on the original diagram. It's x minus 3, so it's going to move the graph to the left by 3, or the translation minus 3, 0. So our new root here is going to be at minus 11. This one is going to go to minus 1. And this minimum point is going to go to minus 6. And your graph is essentially at a parallel shift to the left by 3. I hope you found this video useful. That's basically all the transformations you need to know. Okay. If you need to practice drawing graphs, go to the quadratic section and the completing the square section, because you'll find those videos also very useful. Thanks for watching the video.